All right, we're about to dive into one of the biggest, most mind-bending mysteries in all of physics, antimatter. You can think of it as the universe's missing twin, a substance that, by all accounts, should be everywhere, but it's just gone. So today, we're opening up a cosmic cold case to figure out where it all went and why its disappearance is the only reason you and I are here at all. And really, this is the question that keeps physicists up at night. See, the Big Bang should have created matter and antimatter in perfectly equal amounts. If that's true, then everything we can see and touch, the stars, the planets, everything is literally only half of the story. So you have to wonder, where in the universe is the other half? So to solve this thing, we need to know what we're looking for. Matter, well, that's the easy part. It's everything you can see and touch. It's solid, it's real. Antimatter, though, is its perfect mirror image, its opposite twin. The idea is that for every single particle of matter, there should be an antiparticle to match. Okay, so our investigation kicks off with the number one clue. Before we can figure out where all the antimatter went, we first have to get a really clear idea of what this stuff actually is. You know, the definition itself sounds pretty straightforward, but the implications are huge. An antimatter particle has the exact same mass, it weighs the same, as its matter counterpart. The really big difference is in its fundamental properties, like having the opposite electric charge. It's like a particle's fundamental ID card has been printed in reverse. And this makes it crystal clear. Let's take a particle we all know, the electron. It's got a negative charge. Well, its antimatter twin is called the positron. It has the exact same mass, but, you guessed it, a positive charge. So same weight, but a completely opposite personality. And listen, this isn't just some sci-fi fantasy. It literally started as a ghost in the math. Back in 1928, the physicist Paul Dirac was working on an equation, and his own math told him this stuff had to exist. It was this incredible leap of pure theory. And then, get this, just 4 years later, Carl Anderson actually found one. He discovered a positron in the fallout from cosmic rays hitting our atmosphere. The ghost in the machine was real. So, we know what it is, but the real key to this whole mystery, the reason it's missing, is what happens when these opposites finally meet. And let me tell you, it is probably the most dramatic event in the entire universe. It's actually a pretty simple 3-step process, but with absolutely enormous consequences. When a particle of matter comes into contact with its antimatter twin, they don't just collide, they annihilate. They are completely erased from existence. And in their place, their entire mass is converted into pure energy. And I don't mean some of their mass, I mean 100% of it. So where does all that energy come from? Well, you've definitely heard of the equation that explains it. E equals mc squared, Einstein's most famous discovery. It tells us that mass is really just a super concentrated form of energy. And because c squared, the speed of light squared, is just a ridiculously huge number, even a tiny, tiny amount of mass creates a colossal burst of energy, usually in the form of high-energy gamma rays. Now, this brings us to a huge practical problem. If antimatter annihilates literally anything it touches, how in the world are we supposed to study it? Its whole nature makes it incredibly hard to create and pretty much impossible to store. And yet, we actually can make it. Here on Earth, at big labs like CERN, scientists use these massive particle accelerators to just slam particles into targets at nearly the speed of light. And in the wreckage of those collisions, for a fleeting moment, tiny pairs of matter and antimatter particles just pop into existence. But here's the catch, and it's a big one. The process is unbelievably inefficient. I mean, just look at this. You have to pour in this mountain of energy on one side just to get a microscopic, almost unmeasurable amount of antimatter at the other side. It has got to be the worst return on investment in history. And then, even if you make some, what do you do with it? You can't just put it in a bottle, right? The bottle is made of matter. The second the antimatter touches the walls, poof, it's gone. So scientists use these incredible devices called penning traps. They're basically magnetic bottles that use powerful fields to hold the antiparticles, levitating them in a perfect vacuum so they never touch a single thing. It's a massive scientific challenge. Now, you might be thinking, this is all just a weird cosmic curiosity, totally theoretical. But here's where our story takes a really interesting twist. Despite being so rare and so explosive, antimatter is already being used to save lives, and it might just be our ticket to the stars one day. Right now, today, in hospitals, there are things called PET scans. That P stands for positron, the antimatter of an electron. They use these positrons to get incredible images of what's happening inside the human body, helping doctors spot diseases. And looking to the future, that 100% efficient energy conversion, well, that's the absolute holy grail for space travel. We're talking about an engine powerful enough to maybe, just maybe, make interstellar journeys a reality. So, let's pull it all together. We've defined antimatter, we've seen its power, we understand how hard it is to wrangle, and we've even seen its amazing potential. Now, with all of this evidence in hand, we can finally go back to the scene of the crime, the very beginning of the universe. So here it is, the core of the problem. If matter and antimatter wipe each other out on contact, and the Big Bang made equal amounts of both, then everything should have just canceled out in a huge flash of light right at the beginning. The universe should be empty, just filled with leftover energy. The very fact that we are here, that anything is here, means something must have tipped the scales. And scientists are still hunting for the culprit. The main suspect right now is a tiny flaw in the rules of the universe, an idea called CP violation. The theory basically says that maybe matter and antimatter aren't perfect mirror images after all. Maybe they behave just a little bit differently. And that tiny imbalance, we're talking maybe one extra matter particle for every billion pairs that annihilated, that might be the only reason anything survived. And that leaves us with one last truly profound thought. The universe seems to be built on these beautiful, perfect symmetries. But maybe the only reason we're here to appreciate that beauty is because at the very beginning of time, one of those symmetries was just ever so slightly broken. Our entire existence, everything we've ever known, could just be the leftover scrap from the greatest cosmic imbalance of all time.